To demonstrate optimization concepts, imagine a simple LP problem with just two variables x and y. This can be represented by a two-dimensional graph using the x and y axes to represent the two variables. The constraints can be drawn as straight lines on the graph, and the sign of the inequalities determine which side of the lines define the constraints. The combination of both constraints and the fact that the decision variables x and y are greater than or equal to 0 define a feasible region. So the feasible region of an LP is the region delimited by the constraints. It represents all feasible solutions, that is, all solutions that satisfy the constraints. This graphic shows the feasible region for the telephone problem. The variable desk production and cell production here are abbreviated to be desk and cell. The optimal solution to the LP is obtained when values for the decision variables have been found that are within the feasible region and that maximize profit as defined by the objective function. In this problem, the objective function is to maximize 12 times desk plus 20 times cell, the profit made from the desk phones and the cell phones that are produced. This can be represented as a straight line, for example AB in this graph, by substituting in values for the objective. All the solutions on one objective line, such as AB, yield the same objective value, but this is not the optimal solution. Other values of the objective will be found along parallel lines, such as CD. In profit maximization problems, these parallel lines are often called iso-profit lines because all the points along such a line represent the same profit. In a minimization problem, they are known as iso-cost lines. To find the optimal solution, the iso-profit line is moved up, as this is a maximization problem, as far as it can without leaving the feasible region. The line CD has a larger objective value, but it is still not optimal. Since all iso-profit lines have the same slope, as the objective value is increased, the line representing the objective is pushed further out. The last iso-profit line that touches the feasible region is the largest value possible for the objective function. Here, this is found along the line EF. The optimal solution of a linear program always belongs to an extreme point of the feasible region, that is, at a vertex or an edge. In this case, the optimal solution is x is 300 and y is 850, which determines how many of each type of phone the company must produce to maximize its profit. It is possible that an LP has multiple optimal solutions. At least one optimal solution will be at a vertex. By default, Cplex Optimizer reports the first optimal solution found. This graphic shows an example of an LP with multiple optimal solutions. This can happen when the slope of the objective function is the same as the slope of the constraints. In this case, all points on the line AB are optimal solutions.